Now I'm trying to explain arithmetic unit. This is a simulation. It's a work area with the work area and how this arithmetic unit is working. It describes how this arithmetic unit is working. Now let's select the instructions or the actions. One of them is add. Let's add two numbers. It's the showcase, so we are going to add two numbers only. As you can see, the result is 12,390, which is exactly the addition of these two. Here we have the description of addition, how it is done, and it's fine. Now let's get the 2's complement. Here we will have the second number, 1, 2, 3, 4, 5, and then apply this result. 2's complement is actually 9's complement plus 1, and here we get the 2's complement as this number. And of course there's a description of that later on, you will see. Now let's try to subtract this number and 55 from here and try to get the result. It is 12,290. We first compare these two numbers. It is greater than, when we compare, it is greater than the first number is greater than the second number. So we will get the 10's complement of second number, which is this value. Then we add these two together. There's one carry here, which is of course that carry is the result of 10's complement, so we ignore that carry, and then the subtraction of 1, 2, 3, 4, 5 by 55 is actually this number, and we need 3 clock pulses to complete this subtraction. Okay, let me show you the shift left. Shift left uses the first number as the input. When we shift left, we actually move the data to the left and then add 0 to the least significant digit. This is how we get the shift left condition. And why we need shift left and shift right? We need them because addition, multiplication and division uses these shifts. Here, when we have the shift right, we lose the least significant digit, and the remaining is like this. Okay, let's try to multiply two numbers. And here we have 32, which means we are going to multiply this number or add this number 2 times to the result, and then we will add this number. We will add this number 3 times to the result. Okay, let's see what we have here. We have n times. Now we add 2 times this number. This is this, and get this result. And we shift left this first number register, so there's a 0 behind it, and we move that number here and add it 3 times, 1, 2, 3, so we get this number, and it is n times addition. The other addition is the first number, the total of first number there, and the total of the n times 3n times value over there. So when you add them, you get the correct result. It is actually multiplication of 1, 2, 3, 4, 5 by 32, which is this value. Okay, let's try to compare two numbers. Let's assume that we have this one and another number here. As you can see, result is minus. That means we have a negative. That means the second number is greater than the first number. Let's have another compare here. Let's have the first number greater than the second value, which is 3. That is exactly what the result is. Comparison of number 1. When we compare number 1 with number 2, number 1 is greater than number 2. It's positive. Okay, we did the multiplication. Let's now complete with the division. Let's assume that we have this number and the 32 as the second number for the division. Okay, first we compare the numbers. First we add zeros to the second number so that the length of the two numbers are same. And after that that operation, we compare 12,345 with the new number, second number in the register. It looks like that the second number is greater than the first number, so there's no need to do any division, and we move the second number to the right, removing 1 0, and then I have shown that in the shift right operation. So we have 3,200, and we will compare this one with the initial dividend, and it looks like that dividend is greater than the new divisor. So we will get the tens complement. So we will get the tens complement. So we will get the tens complement of the number and do the addition. Then this is the we subtract the number and get this 9,145. This is greater than the divisor. So we will subtract once more, and then we will subtract once more. So this is 3, number 3, and then we get a smaller value, which is 2,745. It is less than 3,200. So what we do, we shift the divisor to the right. It is now 320, and then we start subtracting 320 from the dividend. And we go to next screen. We will see that here it ends. 320 is less than 180, greater than 185. Therefore, this is 8 times the value. So since it is the 8 times, we go to the next digit. That means we will shift the divisor right one more. It's 32 now, and then start subtracting from this value 185, 32. We start dividing. We have 5 more of these actions, and 25 is left. So we have the 5 there, 25 is left. Let's go to the next screen. Here we compare the result. 32 is greater than dividend. It is finished. We can shift right, but it is smaller than, divisor is smaller than the initial value. So we stop. What we get when we divide this number by 32, we get 385 as the division and 25 as the remainder. So this is what we have as an arithmetic unit. I show all the instructions of the arithmetic unit with an example.